The topic is about the UART protocol. UART means Universal Asynchronous Receiver and Transmission. It is a protocol generally used for serial communication between the two devices. It is a common method for transferring data in embedded system, microcontrollers, and communication devices. It is a synchronous communication protocol. It works asynchronously, depends upon the clock that we choose or select. The topic is about UART protocol. So protocol is a medium to transfer the data between the devices. To go in detail, we need to understand about the introduction of the UART and key features of UART protocol, UART communication basics, UART protocol overview. It includes the frame structure, the process, and the baud rates that will be operated for different conditions, and the error detection, the advantages of the UART and disadvantages of the UART, and typically the UART use cases. Coming to the introduction, UART means the Universal Asynchronous Receiver and Transmitter. It is the hardware communication protocol that facilitates the asynchronous serial communication between the devices. It is commonly used in embedded system and microcontroller for low-speed communication between peripherals and with external devices such as sensors, Bluetooth modules, and many more. UART is widely known for simplicity and it is easy for implementation. The key features involved in UART protocol, it is asynchronous. Here, it would depends upon the clock. No clock signal is shared between the transmitter and receiver. It is a full duplex. UART supports two-way communication, transmitting and receiving of the data simultaneously, and low cost since it doesn't require a clock signal or many wires. It is a simple and cost effective. UART communication basic. Here UART data transmits using two wires. That two wires are TX that used to send the data, RX it used to receive the data. The communication occurs byte by byte and data transmission is done serially bit by bit through the TX pin. While receiver end, it will collect the data with the help of the RX pin. Coming to the frame of the UART protocol, it have you start, data, parity, and stop. Start, it have 1 bit. Data, it have 5 to 9 bits. Parity, it will be the 1 byte. And stop, it will be the 1 to 2 bits. The frame, it consists of start bit. Usually it is the beginning of the transmission. It always 0, the low voltage before sending the data. If there is no data transmission, it will be 1. Data bit, it will be the actual data bit. It will be the 5 to 9 bits. Typically, we can operate within this bits range. Parity, it is the optional. It is used for error detection. It have even parity and hard parity. Stop bit, it is the end of the frame that will be transmitted in the, usually it will be 1 or 2 bits long, represented by 1 voltage. The topic is about UART protocol. Protocol here, the medium for transmitting and receiving of the data. To understand in detail about this, introduction of the UART, key features of UART protocol, the basic communication and the protocol overview, the frame structure and the process involved in the frame structure, and the baud rate and the error detections, and the advantages of UART and disadvantages of UART, and typical use cases involved in the UART will be studied. Coming to the introduction of UART is Universal Asynchronous Receiver and Transmitter. It is the hardware communication protocol that facilitates the asynchronous serial communication between the devices. It is commonly used in embedded systems and microcontroller for low-speed communication between the peripherals and with external devices such as sensors, Bluetooth modules, and many more. UART is widely known for its simplicity and easy for implementation. The key features of UART protocol, it is asynchronous. No clock is required for transmitting of the data. Data can be happen simultaneously, transmitting and receiving. It is a full duplex. It will support two-way communication. Low cost, it doesn't require a clock signal or many wires. It's easy to implement with the TX and RX and the ground wires. Coming to the two wires that used for transmitting and receiving, TX is used to send the data, RX is used to receive the data, where the data will be transferred bit by bit. And coming to the UART protocol frame, it have the start, data, parity, and stop. This is the frame format of the UART protocol, where start represents 1 bit, data represents 5 to 9 bits, and parity it will be 1 bit, and stop it will be 1 to 2 bits. What exactly inside the protocol, the data, it will changes and how it will be maintained. So coming to the frame structure, it involves the data here, start bit. It is the beginning of the transmission. It always 0 during the data transmission. And the data bit, it includes the actual data that we are transferring here. It can be varied 5 bits, 6 bits, 7 bits, 8 bits, and 9 bits. Commonly, it will be operated with 8 bits. Parity bit, it is optional. It is used for error detection, where odd bit is the number of bits that will be transmitted in odd, and even is the number of ones data bits will be even. No parity, it inverts. It's specifically for error detection. There is no error. And coming to the stop bit, it is the end of the frame. After transmitting the data bits, the data will change from 1 to 0 during the start bit, and stop bit is the 1. It will always 1. It indicates that the data will be ended up. Ideal, the process how the data will be transferred. Ideal line, it have the TX and RX lines that remains high 1 always when there is no data is transmission. And start bit, it will be line is pulled low for transmitter to signal that start of transmission. Data transmission, it will be 8 bits of data will be transferred. Always the LSB bit will be transferred first. The parity bit ensures that there is any error happened during the data transmission. It ensures that the failure or the error will be identified with the help of parity bit. And stop it, it indicates that end of the transmission by bringing the low bit level to the high bit. The baud rate is specifically talks about the number of bits we transmitted per second. It refers 9600 means here 9600 bits that we are transmitted per second. The transmission and receiving must be set the same baud rate because both sides the same baud rate, the same speed of data will be transferred between the devices. Coming to the errors, in your parity error, if the parity bit doesn't match the expected value, whether it will be the even or odd, it signifies that there is an error in the frame. Framing error, when the expected stop bit is not detecting correctly, then the frame will give the error as a frame error. And overrun error occurs when the receiver buffer overflows with new data. Advantages of UART, it is a simple, no external clock is required, and the synchronization is not needed. And wide usage, commonly used in microcontroller based projects, especially for communication with the sensors and other modules. And it is a full duplex, can send and receive data same time. Disadvantages of UART, it have a limited distance because of the synchronization. It's only used suitable for short range applications. It's not address based communication. Unlike other protocols, it is a slower compared to the other protocols like SPI I2C. Because of the baud rate, it will be the limitation and the length will be limitation. Typically used use cases are usually it is used to connect with the laptops or the monitors, CPUs. So here from the device to laptop is connected to transmit some data from the tool to the device, and from the device to device transmitting, it will be efficient. And mostly it is used for debugging of the code from the device